Hi everybody, welcome to module P3. In this practical module, we'll be building a web app in Node.js and we'll also be using Git for source code management. This module will also introduce us to the concept of a reverse proxy, which is a very interesting concept to understand because it leads to things like load balancers later on. Our main objectives in this course are to create a project and deploy it online, and also to develop the web app locally, and by locally I mean on your own computer system. We will also try to understand how the deployment works via the cloud.imad.hasura.io console, and that will lead us into a discussion about reverse proxies. So let's head to the console. I go to my console, I can see that there's a button called Create Project. Click on this button. When I clicked on this button, the source code for a basic web app was copied and was created just for me on my GitHub account, and we'll understand how this works later. And that project was created and is now accessible on GitHub and also on the IMAD console. And so now I can go to the code console. We'll wait till all the files are loaded. On this page, which is your coding sort of programming interface, you can see instructions about how to use the console on /code/home. And we can see that we have several different files here. So let's click on a file and you can see that there's some JavaScript code written here, some HTML code here, again some JavaScript here, and some CSS here. We'll understand what these are again in a little bit. For now, let's try to go to our app and see what happens when these source code files are deployed into a web app. When I click on it, I get a message saying that my app is not running, so I need to restart my app. Now, once I click on restart, I can go and try to refresh this page, but the server might take a while to start, and so please do be patient for a few minutes to let your server start. And you can see now that the server has started, and the first HTML page is loaded at "Hi, I am your web app." So this is our project with some basic source code files that has already been deployed for us on a particular domain. Just to see how this works, let's go in and make some small changes. So I shall change "Hi, I am your web app" to "Hi, I am Tanmay and this is my first web app." Right? So I made these changes to the HTML file. And so hopefully I should be seeing that text replace this text here, right? So this "I am your web app" should get replaced. So let's save this and restart our server. Let's go back and refresh this. Please be aware that you'll have to give it some time because your files are being copied again, your application is being built and is being deployed on the server. So you can refresh 2-3 times and you can see that the text is changed, and this is how I can change and deploy code on my web app. Now let's try to understand how this works. What just happened when we had a bunch of source code files? I made some changes, I clicked on a button, and suddenly I'm able to see my server live on my own domain. So for example, if your username is user12, your app would be on user12.imad.hasura.io, and mine, because my username is coco98, my app is coco98.imad.hasura.io. So how is this happening? If you remember, we had discussed a 5-step process last week about how a web app would be deployed. And we said that the process roughly consists of getting a domain name, getting hosting, linking the domain name to the IP that the hosting provides us with, developing the source code or installing a web app or a web server, and then deploying that on that machine so that that web server is accessible on that IP and on that domain name. So let's try to revisit that 5-step process and understand how this console is helping us. The first thing that we had to do is to get a domain name. In this case, we've already created domain names using subdomains. So the domain is hasura.app.io, on which we have the subdomains username.imad.hasura.app.io to help us deploy our web apps on these specific domains. Our second step was to get a server machine and a static IP. In our case, we've got a machine, or actually a large cluster of machines for all the students of this course, and all of them are fronted by a single IP. So this is equivalent to a setup where we have one large machine which has one IP, and all the servers for all the students will be deployed on this single machine. The next thing that we did was map the domain to our IP, which we've done. All the subdomains at imad.hasurapp.io, which is to say star.imad.hasurapp.io, are all domains that are pointing to our IP. So no matter what username you enter with imad.hasurapp.io, it will point to the same IP. And you can try to resolve this by using ping and doing a ping on your username.imad.hasurapp.io and seeing what the response of that ping is, or what the resolution of that ping is. The fourth thing that we had to do was develop the web app or write and install a web server. In our case, since we copied a pre-existing project, because we did not want to write all the code from scratch just to demonstrate this process, we copied the source code files for a web app, and when we clicked on create project, actually what was happening was that project files were being copied from a templated project into our project, and that's kind of where the source code files came from. The fifth step was to deploy the source code files onto our server so that it's live at the domain name that we've bought. In this case, or in the console's case, when you click on commit and restart and the blue button marked commit and restart, these files are saved to GitHub, and then your server is restarted with the latest changes from your GitHub project. Let's now go into a little more detail and actually understand what our GitHub project is and what these source code files are. So if I go to my GitHub account /coco98, you can see that there's a new project that's been created called IMAD 2016 app. We did not create this project. This project got created automatically when we clicked on the button create project. So let's go to this project. And when you go to this project, you can see that there are a few files that are already here, right? And these are the same files that we are looking at in our IMAD console, right? The editable files are files which are JavaScript, HTML or CSS files. Other files are not editable on the IMAD console. If you look at the commit history of the project, which tells us the activity of the project, we can see that there was a change made from IMAD console which says update UI index.html, and this was the change that we made. To understand what this change was, you can go and click on the commit ID, and we can see that this was the last change that we made, which was hi, I am your web app, changed to hi, I am Tanmay, and this is my first web app, right? So you can see the changes here. Now, where did these files come from? Like we said, they've been copied from a templated project or a base project. And if you go to the title of your own page, you'll see username /IMAD 2016 app forked from Hasura IMAD 2016 app. So if I click on this link, this is the base project that everybody will take a copy of to create their own project and to start working. And so when I was clicking on create project in the IMAD console, the green button, what was happening was that this project was being copied into my account, and the project was created for me into my account based on this project. And this process of copying from an existing project or copying from an existing Git project is called forking. So now that we've understood point 4a, which is how the source code was copied to our GitHub account when we clicked on create project and sort of what is happening in the background, let's try to understand the fifth step, which was how the deployment of the web app happened. On this console, everybody's web app is accessible on username.imad.hasurapp.io. And we also said that all of these domains actually point to the same IP or the same machine. So how is this happening? How are multiple domains working on the same IP? There are two ways to achieve this. The first way to achieve this is what we covered in the last practical module, what we covered in an earlier practical module when we used two web servers on the same computer and we ran them on different ports. So the option here is that we can have a big server machine, and every student's server can run on this machine at different ports. And so user 1 server would be imad.hasurapp.io 8080. User 2's would be imad.hasurapp.io 8081. And we could do this, but this doesn't give us good looking URLs. This doesn't give us a feeling that we have our own domain name. And if we really want to have, and somehow we want to achieve username.imad.hasrap.io as our domain. And the only way to do that is using a reverse proxy. So the reverse proxy might be a little complicated to understand, and don't worry about it because it's not extremely important to this course, but it's a nifty concept to understand. So let's look at how the reverse proxy is helping us here. We have star.imad.hasrap.io, which is our set of domains pointing to our IP. The IP itself is of that of a large server machine, right? And we somehow need to have multiple web servers running on this single machine. So the first thing that we do is that we set up a web server called Nginx, right, which is the web server listening on port 80. Now, as you would remember, whenever you connect to a website, the browser by default tries to connect to port 80. You can change that by specifying localhost 8080, and so the browser will try to connect to localhost at 8080. But if you forget the port 8080, the browser will try to connect to localhost at the port 80. So we run a web server, an Nginx web server on the port 80. But we configure this Nginx web server in a special way. What we tell this Nginx web server is that if there's an incoming request from, let's say for example, user1.imad.hasrap.io, and if there's an incoming request that comes to Nginx at user1.imad.hasrap.io, it forwards that connection to a process that is labeled user1.imad.hasrap.io on the same machine. And how is that process running on the same machine? That process is running on some arbitrary port, and we don't care about what port number it's running on, because it seems that the response is coming directly from Nginx, but it's not. Nginx is acting as a reverse proxy to a process that is sitting what is called upstream to Nginx and responding to the request. So that means that user1.imad.hasrap.io goes to this process, user2.imad.hasrap.io goes to another process, user3 to another process, and user4 to another process. This business of creating a front to multiple servers is called reverse proxy, and when we do it for web servers, we call it a web reverse proxy. So what does this reverse proxy do? It is a server, it is a web server that fronts other web servers, which we've understood, and based on certain parameters or based on any property of the incoming request, it can choose to forward it to a particular upstream server. Just to revise our definitions again, we are calling these processes upstream servers, and we are calling our Nginx the web server or the reverse proxy or the web server that is listening on port 80, right? So based on any property of the incoming request, Nginx or the reverse proxy can choose to forward it to a particular upstream server based on that property. In our case, that property is the host name. So based on the value of the host name, which is say user1.imad.hasrap.io, Nginx decides to forward it to a different upstream server, right? But remember that this can actually be done for any property of the request. So you can create your own reverse proxy that is forwarding to different upstream servers based on the URL path. So for example, imad.hasrap.io/user1 will go to the first web server, /user2 will go to the second web server, right? In fact, it does not need to be just based on the property of the request object. It could be based on something else altogether. For example, Nginx can decide that it will forward it to a upstream server that it will pick by random, or it will cycle through them in what is called a round robin method. It will forward the request once to server 1, then to server 2, then to server 3, then to server 4. This is kind of how you achieve load balancing, because if you have many different web servers and you want to spread your connections or your load, your incoming request load across these web servers, then you can have an Nginx that sits in front. And that forwards the connection to a different web server for every new connection, right? There are two commonly used reverse proxies, Nginx and HA proxy. Incidentally, this is exactly how shared hosting works. When you buy a shared hosting account, the shared hosting provider gives you a large machine. On that machine are several users, and for each user, a separate server process is running. But how does everybody manage to get their own servers and all of them seem to be running on port 80? The answer is they're not running on port 80. The shared hosting provider has also set up a reverse proxy or a gateway, and that gateway, based on your own domain name, and in this case it's based on subdomain, But in a shared hosting setup, it's based on your entire domain name. So for example, website1.com could be going to user1, website2.com could be going to user2, website3.com could be going to user3. And this is how a typical shared hosting setup is done as well. So now we've understood what the IMAD console does, where our source code files are coming from, how our IMAD app is even deployed. And just to sum up, what we did on the console was that we created a project, we got a bunch of files, we clicked on a button called restart, and suddenly our server was live on username.imad.hustleapp.io. Now let's try to do some local development and change the source code of our files on our own computer without needing to connect to the internet or without needing to work directly on the IMAD console. So let's try to start our local development. The first thing that we'll do is open up our terminal. So again, I'm just going to zoom this up a little bit so that it's clear for everybody. Now I'll create a new directory where I want to start doing my work. So I'll call that mkdir webapp. And I go inside that webapp. Now I want to copy my source code files here. The same source code files that are on my GitHub account, the same source code files that have been taken from my GitHub account and put into the IMAD console, I also want them here. So what I'm going to do is go to my github.com project. I'm going to click on the button called clone or download. I'm going to copy the URL. And then I run a command called git clone . And if I do an ls to see what files have been created, I can see that a new directory has been created called IMAD 2016 app. If I go inside this directory, I can see that those same files are here, the files that were present here, right? This process was equivalent to downloading a zip file and unzipping the zip file. In fact, we can do that. So let's try to go download zip. You can see that the zip file has been downloaded. Let me copy the zip file from my downloads folder. I'll just clear the screen. So now I unzip that. And you can see that a new directory called IMAD 2016 master has come up. And this also contains the same files, right? So what I did with git clone was similar to downloading a zip file and unzipping it. So let's remove the duplicate copies, and I'll remove the zip file also. I go inside this folder, which was my source code, and now I want to run my server here. I know that this is a Node.js app, and so I need to install all the dependencies that are required. Once again, make sure that you have Node.js and npm installed, and then you can use this to run the command npm install. This will automatically detect what the dependencies of our application are and will install those dependencies. Wait for a second while it's downloading. And if you list the directories again, you'll see that a new folder has been created called node modules. And if you go inside this folder called node modules, you'll see that some files have been downloaded. These are the dependencies of our file. Remember that there is no magic here, right? For example, if you think that npm install is a magical command that is somehow detecting what the dependencies are and installing them, it's because all of these dependencies are in a file called package.json. And if you look at this, there is a JSON object, and this contains the word dependencies, and it has two of the dependencies listed out and their version numbers. That's how npm install knows what modules to install. Now, once our module is installed, all we need to do is run node server.js, and it says that our course app is listening on port 8080. Let's head to the browser. Let's go to localhost 8080, and here you can see that our app is running, and this is the app that we changed, right? So let's try to make some changes. Let's go to the UI folder, index.html, and let's say right? So I save that. Once again, I use the editor Vim. You guys can use the editor Sublime or Atom if it is more comfortable to you. I would highly recommend both Sublime and Atom. These are fairly friendly text editors. You can just double click on the file and edit it and save it, and everything will be the exact same. There is no need to be worried or confused about getting Vim to work on your machines. Now, once you have the setup done, you can just run node server.js, right? We've restarted our server, and you can see that some new changes have come, right? Let's save these changes, right? Let's save these changes so that just like how when we edited code on our console, right, and it got saved to GitHub, which we saw in the commit history, we also want to save our code. So let's do git add UI/index.html, because we've made changes to that and we want to add it to our next commit, right? Similarly, I can add more files that have been changed, right? Once I'm done adding the files that are changed, I say commit and I say -m to send a commit message, which is made some changes locally. And once I make these changes, I will push it back to the central repository, which is on github.com. So I say git push origin master, and it's saying that it's done to https github.com/coco98 IMAD 2016 app.git, right? It's saying that it's pushed. So let's go back and refresh this page, and you can see that the new changes have come up here. And if you click on this commit again, you'll be able to visualize what changes you can see here. Incidentally, github.com is powered by Git as well. So you can run the same command here to see what changes have been made by doing a git log. And you can see the commit history, although not as nicely and visually in a manner that is as visually appealing as it is on github.com. You can see that I've made some changes locally, and before that, the IMAD console on our behalf updated the UI index. Once the changes are here in GitHub, we can even go back to our console and we can refresh this page, and you'll have to wait a while it fetches the files. And you can see that the console has also refreshed itself because it is also fetching your files from your GitHub account. Your GitHub account is the central place where all changes are being kept in this example. And once this is done, I can click on restart again. And if I restart my server, I should be able to see my changes on the server as well. So let's give it a while. And you can see that the new changes have come up here, right? This is exactly the same as what I had on my local host. And now I have it public on the web so that anybody else can also view these changes. So why did we use Git? Why are we using github.com? Why aren't we just copying files? Why did we just not copy a zip file and use that to create a copy of the web app that we wanted to use? Why did we not just copy a zip file and then save it on our local machines, and then once we made the changes, create a new zip file and then upload that zip file somewhere, right? We can collaborate on, for example, on Google Drive or even on Dropbox. The reason why we're using Git is because of all those little features that I showed you. I showed you a commit history. I showed you what changes have been made in every single commit. And Git has the power to let us roll back to a particular commit by if we make any changes, or we make any changes that we want to discard, or we want to pull changes from an earlier commit. All of these things are possible with Git. And doing this is called versioning your code. And Git is an example of a VCS, one of the most popular VCS version control systems out there today. Just an interesting fact, Git was also invented by the inventor of Linux, Linus Torvalds, and he invented both Linux and Git. And he jokes that he's named both the pieces of software after himself. You can read more about Git and version control in general by heading to this link that I've mentioned on the slides. And you should read up and understand, because Git is a powerful piece of software that is very, very useful in all kinds of software engineering. Let's just quickly recap, because we covered a lot of complicated concepts. We have a basic web app with some source code files that have been created by the IMAD team. These were copied when you clicked on the create project button. These were copied and a new GitHub project was created automatically for you, which was accessible on github.com/username/imad2016app. We copied those files onto our local machine by using the command git clone, and we got them on our local machine. And then after that, we pushed it back to our GitHub project, right? And after pushing it back, when we deployed it, those changes were deployed onto a server, right? And effectively what we were able to do was deploy source code from our computer to our server via GitHub, right? This might not be how you typically deploy a web server. In a more typical setup, you might actually end up copying files because you have your own server machine. You might actually copy files or copy your source code files from your local machine to your server. This is not a recommended practice. It is always best to use Git 2 or any other version control system to sort of version your code and then only deploy versions of your code on the server so that no random files or mistakes are copied to your server. Again, it is also important to understand that all the components that we've used are fairly optional. For example, we used github.com for this particular, we're using github.com for this course, but you might as well be using bitbucket.org or gitlab.com, which are all alternative pieces of software that do the same thing. The same thing here being hosting a Git project or on the web, right? Git is a separate piece of software. It is not related to GitHub. It's a separate piece of software that runs on machines. So it's running on the GitHub server, it's running on our computer, it's running on the IMAD server. What you guys should do next is go onto the console, create your projects and start trying to write some code, modify bits and pieces of code, keep experimenting and read up a little bit about HTML and CSS basics to try to modify it and try to make a profile page. You guys can make a profile page that describes yourself and what you do and post the screenshots of that on the forum. You don't need to have the local setup portion to do the basic app development and deployment that is required. That is strictly optional. However, it is recommended because if you're going to go on to do slightly more advanced things and become a developer, you will need to have a local setup ready. You can use the IMAD console for development and deployment. You can write your code directly on IMAD and you don't have to be worried about your changes being lost because all your changes, as soon as you click on commit, are saved to GitHub. Because of the high load that we will experience during this course, your server might switch off due to inactivity if it's inactive for more than 10 minutes. You can always restart it just by going back to your console and clicking on restart. In case you have any issues with the forum, in case you have any issues with the console, please feel free to reach out to us directly on the forum or on our Twitter handles and we'll make sure that we fix it for you. In the next sessions, we'll be looking at server-side JavaScript and understanding how HTML works. We'll also be looking at client-side JavaScript. So although we haven't introduced what the source code files are and how they're working, we will be getting into that from the very next lecture.